Hello everyone, this is A. Basha, Assistant Professor, Information Technology Department, St. Martin's Engineering College. I welcome you all today online video lecture. Today we are going to discuss a very important topic, black diagram of digital computer and 8086 microprocessor architecture. So before going to this topic, so what is the definition of the computer organization and microprocessor we need to see. Later we will move to the other topic, black diagram of the digital computer. So first of all here, what is the computer organization? So first of all, what is the computer organization? Computer organization which is study the structure and behavior of the computer system as seen by the user. So your structure and behavior, it is nothing but the it means how the internal parts of the computer components, how they are going to be functioning, how they are going to be working, how they are going to be internally connected with each other computers. We need to discuss in this particular computer organization, which is called as the computer organization. So next we need to see the what is microprocessor. So here microprocessor, it is nothing but the which is a small integrated circuit in a computer chip which acts as a CPU, that is the central processing unit. So here we can perform the like arithmetic logical unit operations. So here microprocessor, it is nothing but the one of the processor. Here processor, it is nothing but the central processing unit CPU. So here initially the microprocessor were the 4004 microprocessor is there. So later 8008. So later 8080. So later 8085, 8086 they were developed like Intel and Pentium. So like that they are developed. So your microprocessor is a small integrated circuit which on the computer chip. Here we need to perform the ALU operation. So ALU is nothing but the arithmetic logical unit operation. So here arithmetic operations, it is nothing but the like addition and subtraction, division, multiplication operations here we need to perform. So coming to the logical operations, so logical, it is nothing but the here like less than and greater than and less than equals to, greater than equals to, and not and not. So these are the operations we need to perform in this particular like in this one the ALU will be performed. This is the operations. So while coming to the our topic, so here what exactly, so what is the black diagram of the computer? So what exactly it is there here? Nothing but, so here this is the definition of the first one, computer organization, and next one is the microprocessor. So next we will move to the our topic, black diagram of the digital computer. So first of all, what is computer? So why it is called as the digital computer? So first of all we need to see the computer. So later why it is called as the digital computer. So what exactly it is there in the black diagram of the computer we need to see. So here in the computer having some different functional units. So what exactly this one we will see in this session. So first of all, computer, what is the stands for computer? It is nothing but the common oriented machine. So here computer will perform the some like different operations in the central processing unit. So computer, it is nothing but the common oriented machine. This is the stands for. So definition of the computer here, computer is a electronic machine. So in this one we can process and stores the information. So information, it is nothing but the data. So here process and stores the information. Information, it is nothing but the data. So where we have to store the information, it is nothing but the in the storage device is there, that is the memory unit is there. So in that one we can store the our data. So now next here the computer. Who is the father of the computer? It is nothing but the, already we are very familiar with the computer. Charles Babbage is discovered the computer in the ancient stage in the 18th century. So now we have to see what are the basic computer is there. So this is the computer definition. So in this one, what are the different computer categories is there, we need to see now. So here coming to the in this one, so there are the different computer categories is there. So basically computers are categorized as three different categories. So based on the three categories, and so the first one is the based on the size, and second one is the based on the mechanism, and third one is the based on the purpose. So computers are divided into the majorly three categories. First one is the based on the size and based on the mechanism and based on the purpose. So there are majorly three categories. So in this one, based on the size, there are divided into the some different categories like supercomputer, and next one is the mainframe computer, and next one is the mini computer, and next one is the microcomputer. So already we are familiar with this one. So before going to our topic, what exactly information which related is there. So later we can see our topic. So first one is here based on the size, the computer will be divided into different categories. That is the supercomputer and mainframe computer, mini computer and microcomputer. So microcomputer will be divided into the different categories. So that is the lab desktop computer. And next one is the laptop computer, like laptop, and next one is the palm tab. So these are the different computers in the based on the size. So till now what exactly computer different categories, it is nothing but here based on the size and based on the mechanism and based on the purpose. So in the based on the size, supercomputer and mainframe computer, mini computer, microcomputer. So microcomputer will be divided into different categories, that is the desktop and laptop and palm tab. So already we are familiar with this one. So next one we can see the based on the mechanism will be divided into the different three categories. So that is the analog computer, and second one is the digital computer, and third one is the hybrid computer. Based on the mechanism, there are divided into three categories. First one is the analog computer and digital computer and hybrid computer. So here analog is here nothing is there. In analog it is nothing but the continuously changing the data. So here it is called as the analog. So digital it is nothing but the zeros and ones. So here the system will be understandable language is the digital language. So here digital it is nothing but that is the machine level language. The system machine language will be the system will be understood our computer. So here digital language it is nothing but here machine language it is nothing but here zeros and ones. So zeros and ones it is nothing but here the system understandable values are binary language we can assume. So next one is the hybrid. Hybrid it is nothing but the both combination of the analog and digital, it is nothing but the hybrid. So which is the based on the mechanism, it will be divided into three categories. So next one the based on the purpose. So here based on the purpose it will be divided into the two different categories, that is the general purpose computer and next one is the special purpose computer. So computers are categorized into three different types. So one is the based on the size and based on the mechanism, based on the purpose. So based on the size, these are the categories: supercomputer and mainframe and mini computer, microcomputer, desktop and laptop and palm top. So initially supercomputer it is nothing but the very large room side computers were developed. So later coming to the mainframe, same it is there. So here mini and micro, now desktop we are seeing, laptop palm top So these are the like mobile phones like that we can assume. So coming to the next one is the mechanism, that is the analog computer and digital computer and hybrid computer. So this is the information related to the mechanism. While coming to the based on the purpose, there are the different categories: general purpose and special purpose. So general purpose it is nothing but the normally we can use like business or like that we can use. While coming to the special purpose, like what are the examples of the special purpose? It is nothing but like aircrafts, like missiles. So like this way we need to use these special purpose computers. So first of all, computer it is nothing but this is the one of the electronic machine. So here we can store and process the data, which is called as the computer. So founder of who is the father of the computer, it is nothing but Charles Babbage. So these are the small basic information which is related to the computer. So what exactly computer? So what are the different types of the computers is there? So these are the computers. So these are the computer category. So now we will see the what exactly black diagram of the computer we need to see now. So this is the black diagram of the computer, digital computer. So why it is called digital? It is nothing but the system will be understood only zeros and ones. So this is called as the system will understood which language the system will understood. It is nothing but the machine language. The system will be understood only machine language. So machine language here, machine language it is nothing but here the digital computer. Why it is called as the like zeros and ones here we need to use. So that's what it is called as the digital computer. So now let us see here what are the like components of the computer or what are the things is we need to learn in the computer. It is nothing but the so first one is the input device and second one is the ALU arithmetic logic unit and next one is the control unit and next one is the memory unit and next one is the output device. So now here you can see like here input. So what are the input device examples? So how we can give the system to the input? It is nothing but the by using the keyboard or mouse like joystick. So these are the input examples. So here the data will be we need to give the system through the input devices and it will be sent to the particular data. It will be received by the through the CPU. In the CPU all the operations will be performed. So here CPU will be consisting the like control unit and ALU and storage device. So storage device is nothing but the here internal or external storage device is there. So internal storage device and external storage device. So later output devices. So first of all computer. So later here what is the black diagram of the computer? It is nothing but the so what are the functional units of the computer are there in this one input device, ALU, control unit and memory and output devices. So now let us see here what is the input device, what are the examples? It is nothing but the keyboard and mouse, joystick. So these are the examples. So the data will be sent to the particular input devices through the here we need to send the data to the through the input device. We can send the data to the particular CPU, that is the central processing unit. In the central processing unit also there are like different components is there, that is the control unit and ALU and storage. So here for example you can assume we are sending this some data. You can assume here like 7 or like that you can assume. So here we can sending the data. So this data will be so the system will be understood. For example, we are enter 7 or 10 or whatever it may be, that will be converted into the binary code. So here binary code here 7 you can assume here 0111 is there you can assume. So this will be transferred to the this particular CPU central processing unit. So here this is the input device. Input device. So input device examples are the so these are the input device examples. So here input like here keyboard and mouse, joysticks, like touchpads, so etc. These are the input device. So for example 7 is there you can assume. So here the 7 binary value is the say 0111. So this will be sent to the particular CPU. In the CPU, the ALU will be the ALU is there. So next one is the control ALU is there. So in this ALU, so first one is the like input device and second one is the ALU. So in the ALU, all the arithmetic operations will be performed. So here arithmetic it is nothing but the arithmetic. It is nothing but the like addition and subtraction, like division, like multiplication. So all the operations will be performed in the arithmetic. So coming to the logic, it is nothing but the arithmetic logical. It is nothing but the here less than and greater than, less than equals to and greater than equals to. So these are the operations will be performed in the logical unit. So this is the input device and next one is the ALU, that is the arithmetic logic unit. So coming to the third one is the you can assume here control unit is there. So this control unit will be controls the all the components of the in a computer system. So here remaining components it is nothing but the so this control will be communicated with the all the components of the computer system, that is the ALU and input and output devices and memory unit. So all the all these components will be communicated with the control unit. So the major role of the control unit is nothing but so it will be controlling all the components of the computer system. So next one is the memory unit and fourth one is the memory unit. So last one is the output is there. So here memory unit. So memory unit it is nothing but the, so what is the memory? So memory it is nothing but the, here we can store the data. We can store the data either temporarily or permanently. So we can store the data. So here internal memories is there. So like RAM and ROM is there. So in that one we can store the data like temporarily. So external memories is there. So first of all, what is memory? So memory it is nothing but we can store the data. So here what are the different types of memory? It is nothing but the, here there are the two different categories is there memory. So in that one, first one is the here primary memory, and second one is the secondary memory. So here memory unit it is nothing but we can store the data. So memory unit in this one two different categories is there, that is the primary memory and secondary storage device or secondary memory. So what are the examples of the primary memory? It is nothing but the RAM and ROM. So another name of the primary memory unit, primary memory is called as the main memory. So here primary memory, what are the examples? It is nothing but RAM and ROM. And what is the another name of the memory? It is called as the main memory. So while coming to the secondary storage devices, what are the examples of the secondary storage devices? It is nothing but the here hard disk, like what exact pen drive or whatever it may be, it is there, like magnetic tape, magnetic disk and magnetic tape, like hard disk. So these are the secondary storage device. So secondary storage device, another name is also called as the auxiliary memory. Secondary storage device, another name is also called as the auxiliary memory. Auxiliary memory, another name also called as the backup storage device. So here memory will be consisting two categories. That is the primary memory and next one is the secondary memory or secondary storage device, primary memory storage device. So what is the another name called as the primary memory? That is the main memory, and next one is the secondary storage is the auxiliary memory. So auxiliary memory is also called as the backup storage device. So why? Because the secondary memory is also called as backup storage device. It is nothing but the, so we need to store the data in this particular secondary storage device like magnetic disk and tapes, hard disk. So in that one we can store the data. Until unless we can destroy, the data will be safe in this particular secondary storage device. So this is the primary. Primary it is nothing but the RAM and ROM. So RAM it is nothing but the primary, it is nothing but the main memory. So what is the RAM and ROM? It is nothing but the random access memory. So here RAM. So what is the RAM? It is nothing but the here RAM, random access memory. And next one is the read only memory. So ROM it is nothing but the read only memory. So random access memory and read only memory. So just we can see what is the RAM and what is the ROM. So in this one, what are the bands is there we can see. So random access memory and read only memory. So these are the belongs to primary memory. So which is also called as the main memory. So RAM and ROM, these are the examples. So which is the volatile memory, which is the non-volatile memory. So here RAM is the volatile and which is the non-volatile memory. So volatile is nothing but the, so here we need to store this some data. So while we are doing some work, we can assume. So at that time power is gone or the switch of the system, it is nothing but the data will be not available, the data will be not saved in that particular system. So here ROM it is nothing but you can take our mobile or like any system you can take. So in that one manufacturing like HP computer, like any mobile you can take Vivo or whatever it may be. So in that one it will be displayed. So that is belongs to this particular ROM. So next one is the secondary memory, that is the hard disk. So which is also called as the auxiliary memory and which is the backup storage device. So till now this is the memory. So what is the memory part in the particular black diagram of the digital computer? Is nothing but we can store the data. So the ALU is there, the ALU will be performing all the operations. So where it will be performed, it is nothing but the in the memory itself it will be perform the all the operations. And last one is the output device. Output device. Output device. So here, what is the output device? You can see. So output device. So what are the examples of the output device? So before displaying the data, before like displaying the data in the desktop or system or whatever it may be, the data will be stored in the memory unit. Like registers is there. So in the registers also we can store the data in the temporary storage device is there. So in the registers the data will be stored. Like memory and registers are equal. In the register temporarily we can store. In the memory we can store the permanent. So now output, it is nothing but the output device. Like here, like desktop. So like system, any system you can take, like whatever it may be. So these are the coming to the output devices. So here first one is the input device. So what are the components of the digital computer? It is nothing but the input devices. And next one is the, you can assume, output devices. And third one is the ALU. And fourth one is the control unit. And fifth one is the memory unit. So input devices, examples is the like this input device examples is the, like here you can assume keyboard and mouse. So these are the input device examples. So output device is nothing but the like display, like LCD or whatever it may be, display tools. And ALU is nothing but the arithmetic logic unit. And control unit, it control the all the operations. And here the MU is nothing but the memory unit. So memory unit consists of the two categories. So this is the related to the particular block diagram of the digital computer. So for example, here you can see. So here you can see the digital here you can see, for example, 7 we need to execute instruction, you can assume. So how we can execute it is nothing but the, it will be converted into the binary code of the this particular 7. So here binary code of the 7, it is nothing but the, that is the 0 triple 1. So like that it will be executed. For example, you can assume 7, one more 7 you can assume. So here addition we need to add. So where it will be, who is performed, it is nothing but the ALU. So here where it is performed, where the data will be stored, it is nothing but the in the memory. So this is the operation, like 7 plus 4 7. So like that 14 will be displayed. So for example, you can see this is the 7 and so this is the operation. For example, any string you can take, like hello you can take hello. So here there is no addition and there is no subtraction and there is no logic. So how it will be executed, you can assume. So hello is the one of the string or one of the word. One of the word. So here string you can see. So here we need to see the, so what exactly string. So how it will be executed, we need to see. So here hello is there. So for example, hello, this is the one word. So here this is the one word you can assume. So in this one, how many characters is there? HELLO hello. So total 5 characters. So here 5, what is the 5 decimal, like binary number, like 0 1 and 0 1. So next one is the total one word. So what is the one decimal number, like 0 0 1. So like this way it will be, instructions will be executed in a particular arithmetic logic unit. So till now what we are discussing. So this is the ALU component, like here the computer components, that is the input devices and output device, ALU and control unit and memory unit. So now let us see the, so here we will see the like one of the related to the ones we have to. So here we can see the like diagrammatical representation. So how it will be happened, we have to see in this particular segment. So here we can see the block diagram of the computer. So here there are the, so here there are the two things is there, here control path and data path. So control path and as well as data path. So here first one is the input devices, and these input devices. So these input devices, so here CPU is there. So total here this is the output device. So the input device will be through the control path, it will be connected to the all the devices. So here control unit is there. So this control unit through the control path, it will be communicated with the all the devices like components. And next one is the here. This is the data path. So here you can see data path is there. Through the input, it will be transfer the data to the memory unit, and finally the memory unit will be communicated or connected with the internal and external memory device. And this is the memory unit. So here the above is the arithmetic logic unit is there. So these memory unit will be communicated with the arithmetic logic unit after execution of the instruction. So that is the transfer to the memory unit, and memory unit will be transferred to the particular data to the particular output devices. So here input device. So this is the input devices. Input device. These input device will be connected to the like here one of the here arithmetic logic unit, and next one is the control unit, and next one is the memory unit and internal external devices. While coming to the, so this total control part, it will be communicated with the all the components, and through the data part, so the data will be transferred to the memory unit, and the memory unit will be send the data to the arithmetic logic unit, which operation we need to perform either addition or subtraction. So based on that one, so operation will be performed and the result will be stored in the particular memory unit, and the memory unit will be connected to the output devices. Through the output devices. So now we have to see the next one is the 8086 microprocessor architecture is there. So here what exactly 8086 microprocessor, already we have saw the microprocessor introduction part. So what exactly happened in the 8086 microprocessor we need to see. So here this is the until now we are discussed. So this is the until now we are what exactly discussed: computer organization, definition and microprocessor. And next one is the black diagram of the digital computer. So these are the components of the computer, digital computer, and next one is the architecture of the 8086 microprocessor. So 8086 microprocessor overview we need to see. So here 8086 microprocessor, which is the 40-pin integrated circuit, and it is a 16-bit processor, which is a 16-bit processor, and it is the 20-bit address, and it is following the instruction queue, and in this one it supports the pipelining also. So 8086 microprocessor, it is a 40-pin integrated circuit, and which is the 16-bit data processor, which is the 16-bit processor. So here 20-bit address bus is there, and next one is the instruction queue, and next one is the it supports to the pipeline. So now we have to see the what is the architecture of the 8086 microprocessor. So let us see. So here this is the overall. Here this is the overall CPU we can assume. So this part is there. So this is the overall CPU, like here overall CPU we can assume. So this will be connected to the memory unit. So outside the memory unit is there. So there is the external memory unit. So this 8086 microprocessor will be divided into the two different. It will be consisting the two components, two functional unit. So that is the first one is the BIU bus interface unit, and next one is the execution unit. So here what is the purpose of the bus unit? So in the bus unit, what exactly things we need to learn? In the execution unit, what exactly this one? In the execution unit, what exactly we need to learn? It is nothing but, so bus interface unit. So here bus interface unit, it will be fetching the instruction from the memory. So it will be fetching the instruction from the memory. So here bus interface unit. So in the bus interface unit, we need to learn like this is the adder part, like adder, and next one is this is the segment register. So this is the segment register, and this is the byte prefetch queue. This is the 6-byte prefetch queue. And coming to the next unit, that is the control execution unit. Execution unit. So in the BIU, we are fetching the instructions from the memory. So what are the components of the BIU? Otherwise, what are the things we need to learn in the BIU? It is nothing but one is the adder, and next one is the segment register. It is called as the segment register. Segment register. And this is the IP is nothing but the instruction pointer. So this is the offset register, which is called as the offset register, and is the 6-byte prefetch queue. While coming to the execution unit, so what exactly things we need to learn in the execution unit is nothing but the, so this is the general purpose register. So general purpose register, general purpose register, so which is called as the offset register. Which is called as the offset register. So here ALU is there. So here we need to perform the 16-bit operation. Here we need to perform the 16-bit operation. And the next one is the operands, and the next one is the flags. So flags also here total 16 flags is there. So here in this first one, in the particular here in this total 8086 microprocessor, it will be divided into two different categories, two components or two functions. That is the BIU and execution unit. In the BIU, we need to discuss First one is the 6 byte queue, and next one is the segment register, and next one is the adder. So while coming to the execution unit, we need to discuss general purpose register, and so general purpose register. So in this one, offset registers is there, and next one is the ALU, and next one is the control unit, and next one is the operands and flags. So let us see. So in the bus interface unit, what happened? So for example, here registers is there. So here we can see our structure we need to see now. So 6 byte. So here this is a 6 byte prefetch queue. So here in the 6 byte prefetch queue, so here this is a 6 byte prefetch queue. Here we need to follow the FIFO concept. First in, first out. So here 1, 2, 3. So like that it is there. So how we can fetch the instruction? How we can send the execution unit? It is nothing but through the control unit we can send the instruction to the like here through the control unit we can send the instruction to the execution unit. So now here you can see. So here first instruction will be executed first, and second instruction will be executed second time, and third. So one by one it will be executed. So it will be transferred to the control unit. So in the segment register like code segment and start segment, so data segment and extra segment and instruction pattern, so these are there. So in the adder we need to find out the physical address of the processor. So this is the adder. So this is the adder which is called as the adder. So in the adder we need to find out the physical address of the processor. So this is the small information regarding so what happened in the bus interface unit. So this is the information. So for example, first instruction will be fetching. It will be sent to the control unit. So in the control unit it will be executed. So one by one. So one after and next one. So the one after next one. So like that it will be executed. Through the control unit we can send the data simultaneously to the general purpose register and automatic logic unit. So in the general purpose register we can store the data. That's it. And coming to the ALU, so which operation we need to perform? Here we can perform the operation. And next one is the here offset registers, and next one is the operands, and next one is the flag. So flag it is nothing but the so which is the one of the flip flop. In the flip flop we can store the 1 bit data, that is either 0 or 1. We can store the data. So here operands, so operands it is nothing but the here you can see. So for example AH and A. So while coming to the general purpose register, AH and AL is there. So in the general purpose register, so this is the A lower bits and A higher bits. So total it is called as the here 16 bits. 16 bits, that is the AX, while coming to the BH and BL BX and CH and CL CX, it is called as total 16 bits. So why we need to use 16 bit is nothing but these are 16 bit processor. So now we have to conclude our session. So just in the 8086 microprocessor, two things is there we need to learn. So that is the BIU and EIU. So in the BIU we need to learn 3, that is the instruction queue, prefetch queue, byte 6 byte queue, and next one is the segmentation register and adder. While coming to the EU, this is the general purpose register, and next one is the ALU, operands and flags. So this is the overall topic today. We have discussed topic. So this is the thank you for everyone. So this is the today our session. Thank you.